All right, y'all. So like I said, 8.1 is going to deal with polynomial functions. So we'll start off with a few definitions that'll help you in this section, okay? First of all, I'll tell you what a polynomial is. All right, so y'all, a polynomial is a expression that contains one or more terms. Now, terms are separated by addition and subtraction. So y'all, that basically means that each term is made up of a product. Okay. Usually you'll have a number and a variable and then maybe some exponents. Okay. Now, types of polynomial. So we got types of polynomials. So if it's one term, we call that a monomial. Okay, so an example of a one-term polynomial could be something like 3x squared. You can have a negative 2x, y, but these are examples of a monomial. They're one term, okay? A binomial would be two terms. So that could be x plus 3, um, 2x cubed plus 4x squared. So two terms on these, okay? Next, you have a trinomial. And y'all, that is three terms. All right, an example of three terms could be 5x squared minus 3x plus 2. Okay, so you got three terms, and notice how they're being separated by the subtraction and addition. Okay, so that's how we separate our terms of our polynomials is like this, the adding and subtracting. Okay, so that's enough on the types. Now, what this section gets into are these next few terms I'm going to show you. The leading term. So the leading term of a polynomial is the term that contains the highest exponent. So like on this one I'm looking at 5x squared minus 3x plus 2. The leading term would be the 5x squared, okay? So it's the term of the polynomial that contains the highest exponent. Okay, so these can be out of order. If it's out of order, it don't matter. The leading term will still be the term that has the highest exponent, okay? So a lot of times they're in descending order, but if they do have them out of order, you're looking for the largest exponent, okay? So that's your leading term. the leading coefficient. Now in math, when you see leading coefficient, coefficient pretty much means your numbers. Okay, y'all hang on one second. Let me see. Just log it open. All righty, so the leading coefficient is going to be the number in front of the leading term. So for this 5x squared, the leading coefficient would be the 5. For this one up here with the 2x cubed, since that's my leading term, the leading coefficient would be the 2. Okay? So the number in front of the leading term. And once again, if you don't have a number there, like this x plus 3 right here, x is the leading term. It don't have an exponent, so technically the exponent would be a 1 on that. And also the leading term would be a 1. So if there's not a number in front of the leading term, then it is definitely a 1, okay? All right, y'all, the last definition is what we call the degree. So the degree of a polynomial is equal to the highest exponent. Okay? Equal to the highest exponent. So like I said up here on this one with the x plus 3, since it wasn't an exponent, we treated it like a 1, okay? So the degree of this one would be 1. The degree of this second one here would be 3, because 3 is the highest exponent. This trinomial here, the degree would be 2, because 2 is its highest exponent. So what we're going to look at first in here is what we call the end behavior of a graph. So the end behavior, this is what a graph looks like. So this is what a graph looks like as, as the x's. So as my x's go towards negative infinity and positive infinity. We're worried about what's happening to the end of the graphs as they head towards those infinities in the negative and positive direction, okay? So I'm going to show you what we call the end behavior chart, and it gives us an idea of what's happening to the graphs as they head towards infinity, okay? So y'all let me start that. So this is going to be our end behavior chart. Okay, so the first thing we look at are the degrees. So the degree of the polynomial. Now, on the degree of the polynomial, all I'm worried about are the even degrees and the odd degrees. So we'll make two columns. We'll have our even degree and our odd degree. So that's going to be one thing we're looking at are the degrees. Are they even or odd? The second thing we look at is the lead coefficients. The lead coefficients can either be positive or they can be negative. So this is going to separate us into 4 separate pictures. So you got even and odd. On the even, they can have a positive lead coefficient or a negative lead coefficient. The odds, we'll look at them with a positive lead coefficient and a negative lead coefficient. Okay? So the first, if it's even, if the highest degree is even and the lead coefficient is positive, the end behavior of the graphs is that both ends are going to head upwards towards positive infinity. So remember the x squared graphs we graphed, they look like a U. X fourth graphs would look like this in the long run. They would just have a little more terms in here. So that's why they're not connected here, because depending on how high that degree is, there could be a lot of terms in here. But in the long run, both ends will head up. And then what happened if we put a negative in front of them x squareds? It flips them over. So if it's negative in the front and an even degree, then both ends of that graph are going to head down. So a negative x squared, a negative x4, a negative x6. Any even degree with a negative lead coefficient, both ends will head down. Okay? So then we got the odd. If they're odd degrees and positive lead coefficients, these were the ones that sort of look like them little squiggly lines going uphill. So if it's an odd degree and a positive lead coefficient, then it's going to sort of go uphill left to right. Now, like I said, depending on how big the exponents are, determines how many terms might be in here, okay? And then the last case, odd degree, negative lead coefficient. It's going to flip this one over and it's going to go downhill left to right. So even and positive, both uphill. Even and negative, both downhill. Odd and positive, uphill right. Odd and negative, downhill left to right. All right, y'all. So what I'm going to do, let y'all copy that for a second. I'm going to pull up MathLab so we can pull these off of our examples so that you can see how they're going to look. And these will usually be A, B, C, D type answers. And it's the first four doing this, so we'll look at the first four problems on this. All right, y'all. So let me get MathLab pulled up. All right, I'm just about there. All right, y'all. So let's share my screen now and go to MathLab and see what y'all do on these. All right, y'all, let me pull my chat up for y'all. All right, now, so for this first one, they're giving us the four pictures that we just drew, A, B, C, and D. They want us to select one of these four pictures. So I got f of x equals negative square root of 3 x cubed plus 2x squared minus 5x plus 2. So let me show y'all what I would do on this one. My leading term is the negative square root of 3 x cubed. So I'm looking at my degree first. My degree is 3. That's my highest exponent. So since 3 is my degree, it is odd. So I got an odd degree. Now I'm looking at the lead coefficient. Well, my lead coefficient is a negative square root of 3. So it's negative. So I got an odd degree with a negative lead coefficient. So if we looked at the chart, I'd be in the right column with the odd, and then I would go down to the bottom picture that has the negative lead coefficient. Okay, so Jessalyn, you talking about repeat what I'm doing to figure it out or my graph picture? Okay, so I was looking at this polynomial and I'm looking for the term that had the highest degree. So you got an exponent of 3, exponent of 2, the x would have an exponent of 1 and then the 2. So the highest exponent was the x to the third. So that means I had an odd degree of 3. Okay, so that was my degree. 3 was odd. And then I was looking at that negative square root of 3. It was negative. So I had an odd degree of 3 with a negative lead coefficient. So if I was looking at my chart, my second column was the odd degrees, and the bottom right picture on the chart had a negative lead coefficient. So since it was an odd degree and a negative lead coefficient, Julie, what are you saying? B, perfect. Remember, because B is the picture that's going downhill, left to right. So you would punch in B on that one and then check your answer. All right, so what about this one? So y'all, same thing, A, B, C, or D. Let's see, we got P of X equals negative pi x to the 6th plus x to the 5th minus x4 minus x plus 8. The biggest exponent there is that x to the 6th. So that negative pi x6 is my leading term. So 6 is an even degree this time, and pi is negative. So what would I use if I have an even degree and a negative lead coefficient? Would y'all go with A, B, C, or D? So Julie, you're quick today because that is definitely D, remember? 6 is an even degree, so it's the first column, and it's negative lead coefficient, so that would be the bottom left picture where both ends were definitely going down. All right, good job. We're going to check that answer. So let me ask you on this one, y'all. Is the degree of this polynomial even or odd? So I got a negative 3.1 x to the 4th plus x to the 6th plus 0.1 x to the 7th. And Monty, perfect. The highest exponent there is a 7. So 0.1 x to the 7th is my leading term. Everything I need is going to come from that one term. So we got an odd degree of 7. And is that 0.1 positive or negative? So it's positive. So we got an odd degree with a positive lead coefficient. So A, B, C, or D. Good job, Justin. That is definitely D. Because if it's odd and positive, it goes uphill, left to right. So y'all would choose D on that one and move on. All right, y'all. 9 plus 1/9 x to the 4th minus 1/2 x to the 3rd. Is your degree even or odd? Even, good job. Looks like that x to the 4th term is my largest exponent. Is your lead coefficient positive or negative? So positive, good job, because that 1/9 is positive. So y'all, you got an even degree, a positive lead coefficient. So what are y'all saying? B? Yeah, it's going to have both ends heading straight up, and it would be B. All right, y'all, good job on that. So let me go back to my pad now. All righty, y'all. So now we're going to start getting into stuff about zeros, okay? So remember, zeros are solutions. So here we go. Zeros are solutions to polynomials, okay? Remember the other day we said zeros were the solutions to the equations and they were equal to the x value of the x-intercepts, okay? So now let's get into more about the zeros. So they are the solutions to the polynomials. And the reason we call them zeros is because we find them by setting the polynomial. So we find zeros by setting the polynomial equal to zero. Okay? Now, to determine if a number is a zero of a polynomial, then the result must be zero when plugging that number into the polynomial. So if they give me a number and they want to know if it's a zero of a polynomial, we got to plug the number into the polynomial, do all of our order of operations stuff. And if we get a zero, then it would be yes. Any other number, we would put no, okay? So y'all watch this example here. They want to use substitution to determine whether 4 is a zero of, so a polynomial is f of x equals x to the cubed minus 10x squared plus 12x plus 48. So this is either going to be a yes or a no, okay? So basically, I'm going to find f of 4. And I'm going to put 4's in for the x's. If this equals 0 when I'm done, then we'll put yes. If we get any other number, we're going to put no, okay? So we're basically finding f of 4. So that's going to equal 4 cubed minus 10 times 4 squared plus 12 times 4 plus 48. So y'all, the first thing I'm going to do is the exponents. So I got that exponent and that exponent. So 4 times 4 times 4 is going to give us 64. And then I'll bring this down. Minus 10 times 4 squared would be 4 times 4 is 16. And then I'm just bringing everything else down. So all I did on this step was my exponents. Now, if you notice, what I'm going to do is multiply the two places where I got to multiply. So I'm going to bring down to 64 minus 10 times 16 is 160 plus 12 times 4 is 48 and then plus my 48. All right. So y'all, at this point, you can go one by one through this, or you can use your calculator for this. 64 minus 160 is 96, is negative 96. And then negative 96 plus 48 plus 48. I believe that gives me a 0. So let's go check that out on that calculator. So let's see what we got here. We got 64 minus 160 plus 48 plus 48. And hit enter. We get a 0 for that. So if you wanted to do the whole thing, so you could do 4 cubed. So 4, you see above the divide, you got that upside down V. We call that a caret. If you hit that and then put the 3, that'll cube it. And then arrow right to come back down. And then when you come back down, you had minus 10 times 4 squared plus 12 times 4 and then plus 48. So you can push it all in like that and hit enter and you get that 0, okay? So since this equals 0, this answer would be yes. 4 is a 0 of that polynomial, okay? All right, y'all, so watch this. A new definition is called multiplicity. So the multiplicity is the number of times that a 0 occurs. So check this out. The multiplicity is equal to the exponent of single terms or the exponent following parentheses of factored forms. So y'all, let me show you what I'm talking about. So an example of a single term, if I had something like x to the 6, that's a single term. This would have a multiplicity of 6 because it's a single factored term, okay? Now, if it's in parentheses and I had something like this, x squared plus 2 cubed. If it's in factored form like this, it's the exponent following the parentheses, not the one on the inside, okay? It's not going to be 2 on this one. On this one, since we got parentheses with an exponent after it, it's going to equal the 3. Okay, so it's either the exponent of the single factors or it's the exponents outside parentheses when it's in the factor form. Okay, so y'all, what we're going to do, we're going to find those zeros and we're going to tell their multiplicity. And these examples start around number 6 that I'm doing now, okay? So they want me to find the zeros of the polynomial and state the multiplicity of each. So y'all let me see. There's 1, 2, 3. So 3 doing this. So these will start at 6. So for this one, I got f of x equals x squared minus 25 to the fourth. Now we'll say this, I know what the multiplicity will be. The multiplicity is going to be that 4 because it's outside the parentheses. Now what we got to do is take what's inside the parentheses because we got to find the zeros. So to find the zeros, we take each of the factors and set them equal to 0. Okay? So let's find the 0 first. We're going to set x squared minus 25 equal to 0. Now, y'all, if you remember back when I had the quadratic stuff, this is one of those quadratic equation that does not have the x term. So since I don't have the x term, I'm going to solve this by getting the x squared by itself and doing a square root. So to do that, we're going to add 25 to both sides. So the x squared comes down. That's going to cancel. And then 0 plus 25 gives me 25. Now, I got the x squared by itself, the number by itself. I'm going to take a square root of both sides. So square root of x squared will give me x. All right, y'all, what's the square root of 25? Well, y'all got one of the answers. Give me the other answer. What y'all think of this? What times itself equals 25? 5 times 5 equals 25. Oh, I'm going to get y'all. -5. Good job, Mackenzie. Y'all remember, square roots, when you're solving them as an equation, you got to do that plus or minus to them, okay? Because the square root could be a +5 or it could be a -5. Okay? So here's what I'm going to put for my answer. The answer is ±5. That's my zeros. And each has a multiplicity what? So y'all, what's the multiplicity of these two? What did we, okay, good job. It is definitely a 4. So that 4 on the outside of the parentheses became our multiplicity there, okay? So you get the zeros by setting the factors equal to 0, and the multiplicity is those exponents on the outside. And y'all remember, when you solving something and your exponent is a 2, that means you need 2 answers, 5 and -5. If that was the x to the third, we would need 3 answers, okay? So the highest exponent will tell you how many answers you need. All right, y'all, one like 7. Let's see what 7 has. They got f of x equals x cubed x minus 5 squared, and then x plus 9. So I've got 1, 2, 3 factors, which means I'm going to have to solve this for 3 times, okay? Now, oh, this parentheses don't have an exponent out here. So guess what the missing exponent is for these parentheses? So good job. You would treat that like a 1 there, okay? All right, so each of the x's gives me my zeros. So y'all, this one, you got an x with a multiplicity 3. Well, you're going to set the x equal to 0, and that one's done. So anytime you got a single x, I don't care what the exponent is. If you got a single x like this, it's always going to be a 0 of 0. Now I'm going to set x minus 5 equal to 0. And then we'll set the x plus 9 equal to 0. So this one you can't do no work. It's done. Here, to get the x by itself, you're going to add 5. And again, x equals a positive 5. This one, you're going to subtract 9. And you're going to get x equals a negative 9. So here's how this one does. So this one, here's how the answer blanks are. The smallest 0 is blank with multiplicity blank. The middle 0 is blank with multiplicity blank. And then it says the largest 0 is blank with multiplicity blank. So of the 3 zeros, I got a 0, 5, and negative 9. Which one's the smallest? All right, so y'all, let me show y'all. Z got a 0. Okay, there you go, Jess. A negative 9. Negative 9 is the smallest of these 3 numbers. So what's the multiplicity of the 0 that had the negative 9? Well, which factor did we get negative 9 from? We got it from the x plus 9 factor. And on that x plus 9 factor, the multiplicity was 1. So you look at which of these 3 factors gave you the negative 9, and then you go to its exponent. Remember, since this one didn't have an exponent out here, it was automatically a 1. So, all right, y'all, let's see what's this answer. The middle 0 is blank. Okay, so what are y'all saying? Julie and Jesselyn, y'all are saying 0. Perfect. 0's my middle number. So what was the multiplicity of the factor that gave me 0? And that was a 3. Good job. So remember, on the single factors, it's automatically their exponent. So y'all, that means the largest 0 is what? All right, 5. And what is this multiplicity? All right, good job, y'all. That is definitely a 2. All right, y'all. So that's the trick on these. Find those zeros and then answer them questions for the multiplicity and all that fun stuff, okay? So let's do one more of those and then we'll change the theme up, okay? And y'all, this one will be like y'all's number 8. So this time they're giving me f of x equals -6 times x minus 1 to the fourth times x plus 5 to the third times x squared. So this one, they're sort of being tricky. I will say this. There's only 3 factors I'm worried about. This -6 here, it does not even have a variable with it. So since the -6 does not have a variable with it, you can basically cross that thing out. Because there's no way you can set a -6 equal to 0, okay? So that automatically gets canceled out. I've got 3 factors. I'm looking at the variables, okay? So I'm going to set x minus 1 equal to 0. I'm going to set x plus 5 equal to 0. And then here, a single term, I'm going to set that x equal to 0. So once again, the single x is a 0 of 0, okay? Now the other two you actually got to solve. So this one, x minus 1, I'm just going to add 1 to both sides. And I get x is a positive 1. And y'all, this one, we're just going to what? Subtract 5 from both sides and get x is a -5. So my 3 zeros are 1, -5, and 0. All right, so let's see how they're doing this one. So this one has this kind of answer. The 0, 1 has multiplicity blank. Blank is a 0 of multiplicity 3. And then the remaining 0 is blank. It has multiplicity blank. So they want us to fill in these blanks. So y'all, here's the question. What goes in the first blank? The 0, 1 has multiplicity blank. Well, here's where we got the 1 at. And Julie, y'all are quick. You and Jesselyn quick. Because that came from the x minus 1 factor. And it had a multiplicity of 4. All right, good job, y'all. Well, what about this? Blank is a 0 of multiplicity 3. All right, Julie, what do you got? -5, perfect, because the -5 came from this factor, and this factor had a multiplicity 3. All right, then what about this one's got 2 blanks? The remaining 0 is blank. 0, and it has a multiplicity of 2. Good job. So 0, and it came from that single factor that had a multiplicity of 2. All right, y'all. So these ones were already factored for us. So what they're doing now, they're giving us, we got 2 questions coming up in this section, and we actually got to do the factoring for ourselves. They're giving us 4-term polynomials, and we actually got to factor them. But it's doing the same thing, except they're not starting out like this. We got to get it to looking like that, okay? So we're going to find the zeros of the function and their multiplicities. All right, now, y'all, let's see. This one's giving me f of x equals x cubed minus 7x squared minus a x plus 7. Now, y'all, we'll say this. Um, this exponent of 3 here, the highest exponent is a 3. Well, the highest exponent tells you how many zeros you got to find. So that means when I'm all done with this, I better have 3 zeros, okay? Um, so let's try this and see. Now, I'm going to factor this by what we call factor by grouping. Okay? So, to factor by grouping, you're going to make this into 2 groups. The first 2 terms and the second 2 terms. So create 2 groups. The first 2 and the second 2, okay? Now, the next thing I'm going to do, I'm going to factor out the GCF of each group. I'm going to factor out the greatest common factor from both of these groups here. So, you got an x3 minus 7x squared. The greatest common factor is going to be the x's. And the most x's that either one of these has is 2. This one has 3 x's. This one has 2 x's. So the most that they got in common is 2 x's here. So you're going to factor out an x squared. In parentheses, we're going to put what we get when we factor out an x squared. So what do y'all think is going to go in this first parentheses if I factor an x squared out from both of these? So if you had an x cubed and you factored out an x squared, what would that leave? All right, y'all, so let me show you. When you're dividing exponents, when you're dividing variables with exponents, you're basically subtracting the exponents. So an x to the third divided by x squared is just going to leave you an x. And then minus, I have a 7x squared. If I divide out that x squared, that's going to leave me a 7. So let me show you what I did here. I did x to the third divided by my x squared minus the 7x squared divided by x squared. That's what left me with this x minus 7, okay? Now, the second GCF will have the same sign as the third term, so it's going to be negative. And then the only thing common between an x and a 7 would be a 1. So the second GCF is a negative 1. So y'all listen here. Second GCF must have the same sign as the third term. And at least be a 1. You gotta factor something out. And since x's and 7's have nothing in common than a 1, you had to bring out that 1. So what I'm doing here, negative x divided by negative 1 makes that a positive x. And then look here, 7 divided by negative 1 makes that a negative 7. Do you see these parentheses are matching up perfectly? These two parentheses must always match, okay? Now, what you do, you're going to take the stuff on the outside of the parentheses, the x squared minus 1, and put them in the first set. And then whatever's in the parentheses, since those match, they go into the second parenthesis. So the outside, but watch this, y'all. You had x squared times x minus 7. Here you got an x squared times x minus 7. You had a negative 1 times x minus 7. You got a negative 1 times x minus 7. So you're just rewriting this almost like you're undoing the distributive property, okay? So just remember, the stuff on the outside goes into the first parentheses, and then whatever was in the parentheses, we put in the second. All righty. So that basically gives me f of x equals x squared minus 1 times x minus 7. All right, y'all. There's not a multiplicity behind these parentheses. What exponent would y'all put? So, Judy, good job. You would treat those both like a 1 there, okay? So we know the multiplicities. Let's get those zeros. Remember, we got to set each of these equal to 0. So I'm going to set x squared minus 1 equal to 0. And then x minus 7 equal to 0. So notice, this is an x squared. I'm going to get 2 zeros out of this one. That's the x to the first. I'm going to get the third one right there. And y'all, guess what? This is the x squared in the number, so I'm going to solve it by doing the square root like I did a while ago. So I'm going to add 1 to both sides. I'm going to get x squared equals 1. We're going to then square root both sides. So y'all, that's going to give me x equals, all right, y'all, give me the square root of 1. Oh, good job, Justin. You're on the ball now. So that is definitely a 1 and negative 1. So I'm just going to call that a plus or minus 1. And over here, so that's 2 of them, 1 and negative 1. And then here, we're just going to add 7 and get x equals 7. So the zeros are blank. Each has multiplicity blank. All right, what's going in the first parenthesis? What's going in the first blank? Well, Julie, you got 2 of them. What is that third one? All right, there you go. 1, negative 1, and 7. Good job. And y'all, each of these has a multiplicity of what? Good job. They all had a multiplicity of 1. Because remember, since they didn't have exponents, we put 1s here. Okay, so remember, always looking at exponents when they're in parentheses for those multiplicities, okay? All right, y'all, they got another one of those. So another one is pretty much just like that one. So let's see what we're doing on that. And y'all, let me see. This one is like number 10 on this one. All right, so f of x equals 2x cubed minus x squared minus 98x plus 49. So 2x cubed minus x squared minus 98x plus 49. So I'm going to factor by grouping again. So I'm going to factor the first two groups and then the last two groups, okay? And notice, once again, you got a 2x cubed and a negative x squared. The GCF of the first two terms is going to be the x squared. Now watch this. If I factor out an x squared from both of these, 2x cubed divided by that x squared is going to leave me a 2x. And then that's minus. And y'all look at that. X squared divided by the x squared leaves me a 1 there. All right, then we're going to bring down that minus. All righty. So we got a 98 and a 49. What would be the greatest common factor between 98 and 49? And I'll tell you what, on this one, usually the greatest common factor is whatever that last number is. Because 49 will go into 49 one time. 49 will go into 98 two times. So 49 is actually going to be the greatest common factor on that, Jesslyn. So whatever y'all's last number is, that's your GCF, okay? Because 49 times 1 is 49. 49 times 2 gives you 98. So if your smaller number is a factor of the larger number, then the smaller number is automatically your greatest common factor. So y'all, I want to see what goes into parentheses if you divided both of these by that negative 49. What do y'all think is going to go in them parentheses? Mackenzie, good job. It's going to be a 2x minus 1. Negative 98x divided by negative 49 gave me 2x. And then 49 divided by negative 49 gave us a negative 1. And good job, Mackenzie, because these got to match up, remember? Your parentheses got to match up. All right, so now I'm at the point, the stuff on the outside is going to be the x squared minus 49. That's going to be 1 parentheses. The second parentheses will be, since these are matching up, it'll be the 2x minus 1. All right, so here's the thing. What are the multiplicities behind these parentheses? So that's going to be 1s again. And y'all remember, my biggest exponent when I started was a 3. So when we're done, we need to get 3 zeros, okay? So we're going to start out by setting x squared minus 49 equal to 0. And then 2x minus 1 equals 0. So y'all going to get 2 of them on this one. And then I'll get the other one right here, okay? So this one is x squared in a number. I'm going to add the 49 and do my square roots. So we get x squared equals 49. We'll square root that. And y'all, that's going to give me x is a plus or minus. All right, 7 and negative 7, perfect. All right, y'all, this one here, we just got an x. So let's add 1 and then divide by 2. So that cancels, giving me 2x equals 1. And then we're going to divide both sides by 2. So that's going to give me my 1x. And y'all, I don't guess I can do nothing with that. That's going to stay 1/2. So for this one, the zeros are blank. They all have multiplicity blank. All right, y'all. So let's see. My three zeros were what? 7, -7, 1/2. And then we said they all had multiplicity. What'd y'all tell me up here? 1 on that one, okay? Okay, let me see. Let me go to Math Lab and try to get an example for one of those. So what was this? Number 10. So let me see what Math Lab has. Those were what, 9 and 10? Okay, so this one will be another one like number 9, okay? So this one's giving me f of x equals x cubed minus 5x squared minus a x plus a 5. So let me make sure that wasn't like mine. Okay, so they're similar. Okay, y'all, so all right, so we're doing this one. So same thing, you got 4 terms. I'm gonna make my 4 terms. So the first thing you're doing, you're factoring out the greatest common factor of both of these terms, right? So here you had an x cubed and a 5x squared. The greatest common factor for those would be the x squared. Now, x cubed divided by x squared, 3 minus 2 left me an exponent of 1. So that'll be just the x minus the 5x squared divided by x squared. The x squareds basically cancel, leaving the -5. Now remember, when I'm doing the second GCF, it has the same sign as this third term. So the second GCF is going to be negative. Now this one, you had an X and a 5. So their only common factor would have been a 1. So if they have no other common factors, you got to pull out a 1 on that one, okay? All right, so now that -1 is just going to change the sign. Negative divided by negative, make that a positive X. Positive divided by negative, make that a -5. So if you notice, they're matching up. So I'm going to put that into 2 sets of parentheses. Remember, the outside stuff goes into 1. That's going to be the x squared minus 1. And then the x minus 5 inside the parentheses gives me my second factor. So y'all, it looks like everybody's number 9 is going to end up with an x squared minus 1 for one of the factors. The only one that's different is your x minus 5, depending on whether y'all got a 7 here, a 8 here, a 9. No matter what that number is, it looks like it's automatically going to be your second factor, okay? All right, so at this point, I said these both had a multiplicity of 1. And then I just set each of these equal to 0. So this one, I would add 1 and do square roots. Because y'all, that's giving me 2 of my answers. Right? So let's do the square root of that. And that's going to give me x is a plus or minus. Square root of 1 is 1. So 2 of my zeros is 1 and -1. And then over here, I would just add 5 and get x equals 5 as my third zero. Whoops, zeros are. And then each has multiplicity blank. So I had what, a 1, -1, 5. And like I said, each of these had a multiplicity of 1. Now, let me do another one like 10 just to show you. Are you good? You don't need another one of those? Are y'all good then? All righty then, y'all. Let me go back. Let me see what math that had on that pen real quick. Yeah, so they're basically the same as what I was doing. Okay. All righty, y'all. So the last thing in this 8.1 that we're going to look at are how to determine if the graph crosses the x-axis at a zero or not, okay? So, um, if a factor has an even degree or even multiplicity, we'll say, if a factor has an even multiplicity, then the graph of the function is tangent to the x-axis at that zero. So y'all, let me show you what I'm talking about. So let's draw a graph. So it's tangent. That means what it means when it's tangent is your graph is going to come down. It's going to barely touch that x-axis and then it's going to go back up. It does not cross it. It just barely touches it and then it goes back up. This is what we mean by tangent, okay? So, touches the x-axis, but does not cross. So if those factors got an even multiplicity, so let's say this is crossing at 3, so this factor would have been something like x minus 3 squared. Since it was squared, it came down, touched the x-axis, and went on. Now, if a factor has an odd multiplicity, so it's odd, then the graph of the function crosses over the x-axis at that zero. So y'all, if you had your x and y again, and say this was an odd function, it would come up and it's going to cross over the x-axis. Okay, so evens touch it, odd ones cross right on over it, okay? Now, all they're going to do on this stuff is ask us two true or false questions. So true or false. So number 11, if p of x equals x minus 8 to the fourth, x plus 2 to the ninth, then the graph crosses the x-axis at 8, 0. So let me show you what I would do to that. They're giving me 8, 0. So the 0 is 8 on this one. So which one of these factors would give me a 0 of 8? Well, y'all, that's going to be this first factor here. X minus 8, if you set it equal to 0, would give you the 8. So it's coming from the x minus 8 factor. Now, what am I looking at? I'm looking at that multiplicity. That is the even multiplicity. So, if this graph going to cross at that point, or is it going to be tangent at that point? What do y'all think? All right, y'all, so let me go back up here. So if it's crossing at 8, 0, it's coming from this factor. This one has an even multiplicity of 4. So up here we said, if it's an even multiplicity, then the graph is tangent. Well, y'all, they're not saying tangent. They're saying it crosses. So since they're saying it's crossing, this is actually false. And you would say it's false because the graph is tangent at 8, 0. So they'll give you 4 answers. You got to look and see if it's false or true, and then why is it false or true, okay? So let me show you those for number 11 and 12, and that'll be the last 2 for this section. All right, also let me get to 11 here. So let me see if this is true or false, y'all. If your P of x equals x minus 3 to the 8th times x plus 6 to the 5th, then the graph y equals px crosses the x-axis at 3, 0. Is that first true or false? So false, Jesselyn? Yeah, because if I get 3, 0, it's coming from the x minus 3 factor. That's got an even exponent of 8. So it's definitely false. So you got to go to the one that has the right answer. See, B says it's false, but it says the exponent 8 is odd. Well, that ain't happening. We want the one down here that's D that says it's false because the exponent is even, okay? And since it's even, it actually is tangent. So you would check that answer. And let's do this last one. All right, so look, they're giving me P of x equals x minus 3 to the 5th, x plus 5 to the 4th. They're saying the graph is tangent to the x-axis at negative 5, 0. Is that one true or false? So y'all let me look at this. So let's see, negative 5, if that's the 0, which of the factors did it come from? It came from the x plus 5, right? And y'all look at that. X plus 5 has an even exponent of 4 sitting there, right? So let's see. Since that 4 is even, this one's going to be tangent. And y'all, they said it was tangent. So, okay, you got a T there, Jason. Good job. It is actually going to be tangent. So we want the one that's true, but the right answer. So we'd go A because it says 4 is an even number. B, although it's true, it says 4 is an odd number. So you got to pick the one that's got your exponent right. So it definitely would be the A on that one, okay? All righty, y'all. So, um, I'm gonna stop sharing that a second. Um, let's do a 10-minute break, or let's do so 17. Let's come back at 11:25 and we'll knock out 8.2. 8.2 is not. All right, y'all. So 8.2 mainly deals with graphing polynomials. Now, before we actually get into the graphing of the polynomials, we're going to find out how to figure out what's the maximum number of real zeros, what's the maximum number of x-intercepts, and then what's the maximum number of terms a polynomial can have. Don't mean they got to have that many, but it's the maximum number they got, okay? And we're looking at real zeros. Because what happens is sometimes they might have imaginary zeros instead of all real zeros. So that's why we just say a maximum, okay? So for a polynomial, the maximum number of real zeros. So the maximum number of real zeros for a polynomial is equal to the degree. Whoops. Equal to the degree. So if a polynomial has a degree of 5, which is the highest exponent, then that means the maximum number of real zeros is going to be 5. Maximum number of x-intercepts. Well, remember, we said that the x-intercepts, the x value, was equal to the zeros. So basically, if my real zeros is equal to the degree, then the maximum number of x-intercepts equal to the degree. These two will always be the same, okay? And then the third one was maximum number of turning points. Well, this one's different. This one is equal to the degree minus 1. So if this had a degree 5, this one had a degree 5, this one would be 5 minus 1 for the turning points. Okay? So, an example, what if I had x cubed minus 2? So this is a degree 3. So this graph would come up once. It might come down and then shoot back up again. So notice it's got 1, 2, 3 times it crosses the x-axis. So it's got 3 x-intercepts. It's got 3 zeros. But notice it turned once here and it turned once there. So it turned twice. So the maximum number of turns this could do is 2 times, okay? And then the maximum number it could cross the x-axis would be 3 times. So that's why the number of turns is always 1 less, okay? So if this was an x4, let me give you an example of an x4. Something like x4 plus 3x minus 2. Since that's an exponent of 4, the most it could cross would be 4 times. So it might come down, shoot up, come back down, look like a W almost. So at 1, 2, 3, 4 times it can cross the x-axis. That's the maximum number of times. And then look at the terms. It turned 1, 2, 3 times. So an exponent 4 would turn 3 times at the most, okay? Now here's the thing about this. The reason we're talking about real zeros and stuff, because something like this, it's possible this graph might come down, it might turn and do something like that. These zeros right here are going to be imaginary because it's not crossing the x-axis. So this one would actually have 2 real zeros, but the other ones would be imaginary because they're not crossing the x-axis, okay? So that's what we're talking about. The maximum number it could have would be equal to the degree, the maximum x-intercepts equal to the degree, and then the maximum turning points would be the degree minus 1. So y'all let me see what y'all do on some of these examples. All right, y'all, so you got f of x equals x to the 5th minus x to the 4th plus 4. What is the maximum number of real zeros for that polynomial? So what I'm asking then, basically, what's the degree of that polynomial? And that would be 5. Good job, because that's the highest exponent. So watch, it's going to make you check it. What's the maximum number of x-intercepts? We just said that's going to be the same as the first one, because x-intercepts and zeros, good job, are going to be the same. So we check that. And y'all look at this. What's the maximum number of turning points? And that's going to be equal to the degree minus 1. Good job, Jessalyn. That would be a 4. And y'all, that's all y'all are doing on these first. Let me see a tricky one here. Let me do the third one. So the second one's just like that. Let's see what y'all do to the third one. So y'all on this one, what's the maximum number of real zeros? 6. Good job. So they're out of order, but you had to find the highest exponent. Good job. So what would you put for the maximum x-intercepts? All right, good job. Remember, those two were always the same. Good job. And then, you know what's next? Maximum number of turning points is 5. All right, y'all. Then we're going to get into some graphing here. So let's see. For this one, now this is the same as we started in 8.1. You got f of x equals 1/4 x squared minus 5. Now remember, that's an even degree of 2 and a positive lead coefficient of a 1/4. So which picture was it if it was even degree and a positive lead coefficient? Would y'all go with A, B, C, or D? Justin, I think you're good, right? B, even degree of 2, positive lead coefficient. If you looked on the chart, that one had both ends going up. So then check your answer. So a lot of these is just doing that. Um, Same thing here. Which picture? You got an x to the 5th minus x4, x squared plus 7. You got an odd degree of 5, and you got a positive 1 in front of it. So it's odd and positive. Yeah, that's going to be B again, right, y'all? Because look at B. It's going uphill left to right. So Julie, you and Jocelyn got that one. It's definitely B on that one. All right, so now is where you see these numbers on the bottom. It says choose the graph, and then it says all graphs, -5, 5, -30, 70. And they're saying X scale 1, Y scale 10. This is what window they recommend you set the calculator at to get one of these four pictures, okay? So it looks like A and B are really close, except A is crossing at that notch, the first notch, and C, if you look, is crossing at the second notch on the bottom. So let's see. Um, so let me show you. You're going to go to your calculator, and y'all let me see what they're setting that window at. So let me draw this real quick. F of x is x to the fourth minus 2x cubed plus 10x squared plus x minus 20. They want me to do -5 to 5, -30 to 70, and x scale equals 1, y scale equals 10. So this is basically what it means. Each mark on that is either going to be by ones or tens, okay? All right, y'all, so here we go. Calculator. We're going to go to y equals. Now, we'll put in my polynomial first, x to the fourth. So x, arrow up for the exponent 4, arrow right to come down, minus 2x, arrow up for the exponent 3, arrow right to come back down, plus 10x squared, plus a x minus 20. Now, you're going to go to window. -5 and 5 are the minimum and the maximum x's. So we'll make that a -5, enter, and then a 5, enter.
I feel like I'm working the whole week. I feel like I'm working the whole week.
Let's see, is my x scale, that was 1. All right, now let me go down. My y minimum is the -30. My y max was a +70. And on that y scale, they said go by tens. So now I'm using their scale. When I hit graph, it should look exactly like one of their pictures. Now y'all look at that. Mine went down to the second mark is where it's crossing over. So let's see. Let's go back to the math lab. So mine is at the second mark. So y'all, if you look, A is crossing at the top mark. C is crossing at that second mark down there. So, yeah, I'm going to go with C on that one because it's crossing at that second mark. So when you set your table to match theirs, you can see that you're going to get exactly like one of their pictures. Then y'all look at this one. They didn't give you the scale to use, but look at these graphs. They're going from -10 to 10 and -100 to 100. So that's what I would set my scale at to get one of these four pictures. But y'all, I don't even have to do that one on this one because these are got one going uphill, both down, one downhill, both up. That's a -x to the fifth. So Jessam's saying C here. So let's see. Odd degree, negative lead coefficient. So Jessamine, that's perfect. That one's going to go downhill. So see, when I know, when all my pictures look different, I don't even have to graph it. I can look at one of the, what about this one? X to the fifth minus X to the third. That's an odd degree, a positive lead coefficient. So Justin, you said C, so let's look at C. Yeah, that was going uphill left to right like we said if it was odd and positive. All right, y'all look at this one. Now it's a little bit crazier on this one because but I'll tell y'all a trick on this one. You see you got x minus 4, x plus 1, x minus 7. If you was to multiply all four of them x's, x times x times x times x, you would get an x4 out of that. It would have a positive 1 in front of it. So, knowing that it's an x4 and a positive 1, I'd probably go with C. But y'all, let me show you. Let's graph this one. Now look at this. The x's are negative 10 to 10. The y's are negative 100 to 100. So we're going to graph this one. Let me write this down. All righty, so y'all, I'm going to go to my calculator.
My mommy doing me around.
So the y equals, I'm going to clear that.
He not coming in, TT. He probably look rough. I don't know.
Oh, y'all, hang
Waiting on
on
her to
here.
call.
Okay, I think I got it now. All right, let me go back. All right, y'all, so that was a x times x minus 4 times x plus 1 times x minus 7. All right, so I'm going to hit the window. They didn't tell me what scale to use, so I'm going to use negative 10 to 10. I'm going to leave that on 1 for x scale. Y minimum was negative 100 to a positive 100. And I'm going to leave that on 10 and go by tens. So what I want to look at is the graph. Then y'all look, it looks like a W on the right side, right? So let's go back to Math Lab. And the only one that looks sort of like that W would be C. A looks like an M. B is nowhere near what I needed, and D is not either. So the only one would have been C on that one, okay? All right, so let's see what we got. A is going downhill. B, both going uphill. C is downhill. And then D is uphill. So let's see. Looks like A and C are both going downhill. Now let me look. It's got the same window, negative 10 to 10, negative 100 to 100. So let me punch this one in. G of x is a negative x, x minus 2 squared, x plus 3 squared. All right, y'all. So let me go graph this one. So y equals, I'll clear that out. Oh, you also had a negative x minus 2 squared, and then x plus 3 squared. All right, so we want to see the graph because my window was the same as the one while ago. Whoops, let's see what I did. What did it not like? Oh, I hit subtraction instead of the negative key. All right, so that was negative x. I accidentally hit the subtraction. So see if you tell it where your error was and you go to it, it'll tell you, hey, you got the wrong symbol here, okay? All right, now let's hit the graph. So look, it's going downhill. So it's touching at the negative 3 over here, and then touching at the positive 2 on the right side. All right, so let's see which one we're going with. So it looks like A, right? Touching at -3 on the left side and then +2. You see the difference? This one's touching at -3 over here and +2. If you look at C, it's touching at -2 on the left side and +3. So we needed the one that was at +2, -3. So we would have went with A on that one. And that's the trick on these is just graphing them and seeing what you get. So this one is both up, this one's down. This one, they're both up. And then D, they're both down. So I'm going to look, it looks like most of these have been the pictures that are similar. So let's see if we get A or C out of this. Now the difference is on A, the left side is touching at -1, the right side's touching at 2. On C, the left side's at -2, the right side's at 1. So if it's one of them two, we're going about to see, okay? So x plus 2 squared, x minus 1 to the fourth. Now look at these graphs. They go -10 to 10 for the x's, -25 to 25 on the y values. And if you look, it looks like the y values are going by fives. 5, 10, 15, 20, 25, okay? So I'm going to make them go by fives on the y values. All right, so I'm going to go to y equals, clear this off. I had x plus 2 squared, and then x minus 1 to the fourth. All righty, so I'm going to go to window. The x's were -10 to 10, so that was good. The y went from -25 to a +25, and then they looked like they were going by fives. All right, y'all, so let's hit graph and see what's going to happen. So it was the one that looked sort of like the W uphill. And look, the left side is touching at the -2. So let me go to the picture where the left side was touching at -2. So A, the left side touches at -1. So y'all, looks like I need C right here, right? The left side is touching at that -2. Yo, and I bet 8x to the cubed, odd exponent, positive lead coefficient. So it's either going to be A or C. So let's look at the difference. C is crossing way up here, looks like 50 something. And A is crossing right through the center. So it's either going to cross through the center on the y-axis or it's going to be up a little bit. So y'all, let's go graph that and see which one we get. Oh, let me look at the table real quick. And this is going from -5 to 5, -250 to 250. So it looks like the x's are going by ones and the y values are going by 50 on that, okay? All right, let me see. I'll tell y'all a trick. That last number, that 54, when you got a number at the end that don't have a variable, that's the actual y-intercept of the problem. So the number at the very end that don't have a variable is the y-intercept. Well, A says that y-intercept is 0, crossing right through the center. And look at C. C looks like it's up at least around 54 or so. So I'm going to bet on this one being C for us, okay? So let's put it in. 8x cubed. All right, arrow down. Minus 6x squared. minus 72x plus 54. All right, and that window was negative 5 to 5. I wanted that on a 1. This was negative 250 to a positive 250. And the y's look like they went by 50 to me. All right, ready? Let's hit graph. And y'all look at that. It is the one that was raised up a little bit. So on that one, we're choosing C. That was raised up just a little bit for us, okay? And then you're going to check your answer. Now, y'all watch this. On your calculators, if you want to reset it to where it's back to a normal window, so let me show you this. So to reset the graph to a negative 10, 10, you can hit zoom. So hit the zoom button and go down to number 6 for zoom standard. Whoops. Number 6, zoom standard and hit enter. And your graph goes back to a 10 by 10. Watch the window. Sets it back to a negative 10 by 10 for you, okay? So zoom 6 sets it back, okay? All right, y'all, any questions on that? Um, so y'all, the main thing on that 8.2 was getting used to setting your windows on that calculator, okay? And zoom 6 will reset that calculator back to a 10 by 10, okay? So y'all, 8.1 support, I took that out. Um, I took out most of the support for this chapter because 8.1 support just went over some of the polynomial definitions, and we did them when we started this lesson. So you won't have 8.1 support, okay? So there pretty much won't be any support through this chapter 8 because I'll sort of cover what you need to know for it in those lessons. And y'all ain't gonna lie, chapter 8's got enough work without all that extra support on it, okay?